Hello everybody and welcome to another Autodesk Inventor tutorial. My name is Mr. Galindo. We're going to be using computer-aided manufacturing again as our subject matter. So today we're looking at how we would actually use a program to cut out the whole profile of our vehicle. This is done using a 3D milling program. Now I've got a setup created. I've already created a drill program. Now I'm going to create a parallel milling 3D program. Now to do this, if you've already set your tool up, it should automatically come across. You'll just be able to check that by checking the spindle speed is correct. And then you're going to select your geometry, and rather than creating silhouette, you can see the differences here. If you'd like to pause the video and read it, we're going to do selection of a machining boundary. And this is going to be our profile that I've created and talked about before, just here. It has the rear line here on the origin, so that it doesn't go over into our fixture, and it stops before 210 millimeters, or exactly on 210 millimeters. However, it goes above our vehicle or below our vehicle from this perspective by about 4 millimeters or so. I also like to make sure that I've got contact only selected. Okay, that basically means that it will only machine where it needs to. If you can see this visualization here, it won't machine across the middle there where it doesn't need to, which cuts down a little bit on our time for manufacturing. Now, when we go to the heights, we need to make sure that our clearance again and the bottom height is correct. The clearance I'm going to change to 2.5 offset, so it's at 40 millimeters, which is what we want. And the model bottom is going to be origin and then -4. Because we want to just overcome the curvature on the end of a ball mill, which is 3 millimeters, so we go 1 extra millimeter. Then we're going to go passes. Now the passes is where you actually define the information about where we're going to machine and how. So for example, it basically should start by looking like this, and there shouldn't be any changes. I'm going to let this be created, and then I'd like to have a look at what that code looks like. But just before I do, I'm going to select the linking and select an entry position. I like to use this entry position here down the bottom of our vehicle. Selecting OK, and it will generate a code. You can see that 0% there on the left. It will ramp up until it gets to 100. Shouldn't take you more than a couple of seconds. And once it's done, you can see that we've got a blue line that outlines where the cutting edge of our tool will be moving, so that it will actually cut over our vehicle. Now, just to double check here, you'll notice that it's going in a parallel with the vehicle kind of angle, and if I simulate this, you can see that visualization as it cuts over. You'll also notice that the passes between the vehicle are really far between. There's quite a large gap, and can you see how as it's manufacturing the edges between those passes have got a groove. Now that groove is because the round edge of the cutter, if I can hold up my pen and visualize it here for you, it's got that round edge, it's going across and it's moving over so far that as it goes past again, it doesn't really get to touch the bottom, it touches near the edge, and so you end up with these grooves. Now we can change this with the settings. So we close out of the simulation, go back into the parallel by double clicking, go to the passes and change the step over to 10% of the diameter of the cutter. If you remember the diameter of our cutter, it was 6 millimeters. 10% of that is 0.6. Right? So the step over is now 0.6. The other thing is the pass direction. I don't want to go long ways along my vehicle. I would much prefer to go horizontally or cross. So I'm going to type in 270 millimeters for the pass direction. Having clicked that, I'm now going to go OK. Let the code generate. This one takes a little bit longer because it's got a lot more passes. That's the name we use to describe a continuous path over and then back again. And it should just appear about now. And oh, no, I spoke too soon. Here we go. We can simulate this, but straight away we can see that the passes are at a different angle. They're going across. They're going all the way down the edges of our vehicle, and then they're going all the way to the end, but they're not going outside that boundary. Now if I go simulate, And we can see this as it goes. It's going to manufacture along, and if I speed this up really fast, you'll notice that it takes a longer time to go over the whole vehicle, but if you zoom in, those little edges are a lot smaller, much smaller, and so the finished quality of our vehicle will be greatly increased, which can't stand on the amount of time you've got to sand it back till it's finished. Okay, and there you go. Now, just double check at this point that along this green edge you don't get any red marks. If you get a red mark, it means that you've selected something wrong, and the machine bit will be hitting one of our fixtures. That's what it indicates. You can click on it and tell it what it is. It'll tell you where it is. Okay, we're going to stop that, and that is how to create the parallel passes for our parallel program for machining your CO2 car. Alright, I'm going to save that now at this location. I'd click the save button, and that's basically the harder part's over. Well done.